So there are two special truth tables that you need to be aware of, and it isn't the tables themselves that are significant so much as the final results. All right, so let's take a look at this one. I've got P and not P. All right, well, I want to make a truth table, and there's only one variable, right? So I only have two rows, and there's only two possibilities here. I could either have P is true or P is false. All right, so let's write those in. Right, this is going to be just P. This is going to be not P. Right, that's going to reverse the values in the P column. And then I want to do an and. Right, well, true and false is false. And false and true is also false. So look at what happened here. Right, this statement, regardless of what the values of the individual parts are, this statement is always false. Right? And a statement that is always false, it has a name. It's called a contradiction. And it actually has its own special variable. Right? If you're looking at a truth table and you see something like P and C, and it'll usually be bold, that means what is the value of P and a contradiction. So what you'll do in your table is you will, since the contradiction is always false, you'll put an F in every row for that column. So here we have another example for us, and it's very similar to the last one, right? It's P or not P. So I'm going to start off the same way. Only two possibilities, true and false. And I'm going to copy them over here, and this is not P, and so this will be false and true, and I'll have an or here, right? True or false is true. False or true is also true. So look what I have now, right? Now I have all truths. So this statement is always true, regardless of the inputs. And this one also has a name. It's called a tautology. Yes, sorry, was second guessing my spelling over there. Tautology. There you go. O-L-O-G-Y. That's it. And it also has its own special symbol. If I wanted to say, if you see something like P or, and again, it's usually done in bold, lowercase t, you would put trues in every column for that one. So let's actually take a look at this here. What is P and a tautology? Well, I'm going to put true and false for P, just like I've done before. And then I'm going to put true and false here. Remember, a tautology, that T, it's always true. And then I'll do the final column the way I always do. True and true is true. False and true is false. And there's your final result. All right, so where are we going next? Well, the next thing we're gonna think about is this idea of equivalent statements. And this is something that we always kind of come down to in math, right? In algebra, we call it equals. In mathematical logic, we call it equivalent. Two statements are equivalent if they always get the same results, right? So that's what we'll be looking at in the next section is how to make that determination.